Look at this phone. This is we modified the code from CyanogenMod. The Seattle company, they took all the source code from Android. They built their own version of this phone. So we download all the source code from CyanogenMod, and then we translated the Java framework into C++. We translated the Java class library to C++. If we can run this far, pretty much we translated over 90% of it. You believe that, right? That's 4 million lines of code. 4 million lines of code, you see even WeChat is running.
Yeah.
If we can get WeChat running, that's a lot of code.
Yeah.
And if you got a media player, and you got like a calculator,
Wow.
but then you pretty much got this is an alpha version or alpha 2 versions of. This is a C++ phone, okay?
It's incredible. It's amazing.
It's an Android compatible C++ phone. We're going back to the old Windows. When you need Java, it launches just in time.
So the WeChat app and all the apps you have on this phone are just regular Android apps that you download through the Google Play Store.
Yeah. You download it from the App Store. But what I'm saying is that we download the ones only that runs, right? There are some ones that don't run. We don't. I'm so honest. Yeah.
That's great.
厉害.
厉害. Yeah.
就是厉害, yeah. It's sick.
The reason why doing this, 2 reasons. That's actually Foxconn's investment.
Yeah.
The reason why we do it for 2 things. Speed is none of the 2. Doing it in C++ is not for speed, because this one is not much faster than Android. About the same, comparable. The reason why we want to do this, basically we're building a C++ versions of Java VM. If you look at the Java VM, it's a VM, right? But then Java VM has 2 problems. One is it cannot run 100% of the apps. You need a JNI. Because if you need a game engine, if you need a multimedia codec, if you need a security, then you need a JNI to go into Linux. When you go to Linux, then the DDoS attacks, the middleman attacks, the fake identity comes back. So when you're running inside the sandbox, you cannot launch a TCP/IP directly. You have to give me a website. You're saying, give me a URL, open up a website. Then I give you a website object. Then you do get and post. We fake the website for you. So you don't directly put an IP packet out. You don't see the 8.8.8.8 DNS address, because you never see a real DNS address. Even if you see a 8.8, we fake it for you. It's not there. You see what I'm saying? We fake it for you, because otherwise, if you run on Linux, you can run multiple packets out. One for the real destination, one for the copycat, or one for the security leak. And if you launch a million those infected machines, you launch DDoS, right? So if you are running inside this kind of virtual machine, you essentially will limit the possibility of DDoS. Will essentially limit the possibility of a virus, because that's one virtual machine, Java VM or C++ VM. You want to inject a virus into it, then when the game is over, I destroy the VM. I destroy all the storage. So what are you going to do? You're going to infect who, right? One machine, one app. Who are you going to infect? You want to steal information from operating system? By all means, right? It's all yours. It's all open source. It's all yours. Secondly, we want to do it is because we want to do this, and then we want to run this virtual machine on Ubuntu or on the cloud or in so-called ambient on the smart router. So they are all virtual machines talking to virtual machine. Using a UUID, you'll find another virtual machine. So then you feel confident passing so-called values. Because of our loader will load it and see if you still have the right. If you don't, you can resell it. So when you run it, so we have a URL, you point to a game, then you like a movies. So you load it into this virtual machine. You run it. That's a different business. Because if it's a media player, the middleman will take advantage of you. If you are the game yourself, you are in control. So that's a completely different model. To a consumer, it's the same thing. It's reading a book, play a game, or watch a movie, but we cut off the middleman. We cut off the channel. So that's why the only way you can do it, you achieve end-to-end. Otherwise, we couldn't. Basically, we took over all your network traffic, right? So then you have to be end-to-end because this is elastic, that has to be elastic. Otherwise, how can I take over your network traffic? So it has to be end-to-end, and it has to be in the C-level.
So how lightweight is Elastis OS? Because I know like these days there's like Unix versions like Alpine, which are
No, we're not Docker, right? If you look at what's a virtual machine, you know, I'm old enough to back pre-DOS days.
Yeah.
Old enough when I learned computer science, there was not even DOS, right? But I learned programming paper tapes and core memory, just core memory and Fortran basic. And, we do toggle switches, no BIOS. No BIOS. Memorize 13 instructions. I still know it's a 13 instructions. It's called a Nova machine. It's an operating system called Nova. Actually, it's by CDC. Data control, CDC, right? Control Data Corporation. And there you do 16-bit, and then you do toggle switch, and 01. Basically, it's a hex. You know, you remember the hex, and you toggle the switch, and then saying AK store, and basically you put in word 0. Then next one you put in word 1 and word 2, word 3. Then after you put into word 12, then there's a toggle switch called run. And if you turn it on, there's a paper tape machine. Start running, right? Then you basically whatever the bits you read from dumping, right into memory, right into the core. That's how the machine got booted up, right? And now we're pretty much saying, what's a virtual machine? Virtual machine is just Unix process with a storage. Single process with the storage. That's called a virtual machine. So we're going back to DOS days. No more multi-processing. No more multi-threads, but no more multi-processes. Why do we need multi-processes if we have multi-virtual machines? Each virtual machine has its own storage, like Android. Each app has its own ID. When you have your own ID, you have your own home directory. When you have your home directory on Linux, essentially that's your own hard drive.
So it's essentially working like Docker, where you only have one service in one VM, and then
we don't care about Docker, right? Because that's extremely lightweight. Yeah. We just care about our little bit of runtime and our own class library. Why do we need Docker? And if you launch that and we give each one a different ID, then you read the Linux user directory. We have a built-in daemon to sync your local drive with your cloud drive. So you're always, you modify something. If you say, okay, it's a temp directory, then we don't sync. If it's you need to write it up, the file property, then that background process will sync it with your cloud drive.
Right. So these digital assets, you said like we're going to be storing them in the cloud. Do we get to choose like just Dropbox, whatever, or like is there a specific?
We hope. Basically, we have two kinds of file systems. So you see this Zapier guy saying, we're going to build an IPFS.
Yeah.
IPFS actually is for the common area, for the bin, for the app store.
Yes.
Because the web is the computer. Where's the app store? I mean, basically, you don't install app. Everything is on the web, right? So IPFS is where you app store is just whether you're buying the capability to execute. It's there on the IPFS. Or if you have some data to share, you put it in a public directory, temp directory, so everybody can access, right? That's IPFS. But if you want something of your own, so you're in control, you want to delete, you want to archive to your DVD drive, then you put it in Dropbox, you put it in OneDrive, you put it in your home NAS, then that's your personal drive.
Right. So when you want to transfer this and sell it, then it just automatically destroys itself.
No, it's not going to destroy. It's just going to rescramble with your ID, your public key, his private key, that kind of thing. You just encrypt actually basically this piece of hardware. If you sell 10,000 copies of it, and it's scrambled, and then you are purchasing one of the icons, right? Yeah. The icon's a little manifest. You purchase that, you scramble that as one of the 10,000 copies. You resell that, and with the capability, you can access, you can cache the file to your local phone eventually. So basically, we treat the web. 92, some macro is saying the network is the computer. So we're saying the web is the computer, and so everything. I mean, in the old days, computer meaning multi-process. Now we're saying the computer is a multi-virtual machine. Right. So the virtual machine could spread out of the web. And if you think that's a huge one computer with the virtual machines on demand loading, on demand shutdown, and then that's the model.
Right. I guess at that point, there's really no need for an audience.
No. Web doctrine, right?
Yeah, we don't need that.
No. Yeah. Then if you want to, because that's just a C++ virtual machine, you want to port Python to it, you want to port Java to it.
Right. Because when it's written in C, you can pretty much run it in any universal device out there.
Yeah.
Right?
Yeah. That's, I mean, I know Silicon Valley hates Microsoft. But you have to look into, because we don't have that many documentations, right? You look into several things. First of all, Microsoft is a universal app. One app, I mean, basically you download from the Microsoft Web Store and runs on the phone, runs on the pad, runs on the PC, runs on the Xbox, runs on the server, runs on the Xbox, choppy, embedded, like ATM machines, the gas pumps. They used to have 5, right? Windows CE for phone, Windows NT for PC, Windows Server for the cloud, Xbox for the Xbox, NT embedded for ATM machines. So Microsoft issued 5 distributions. If you look at Chrome OS, Android OS, iOS, Mac OS, because they haven't done the Xbox, they haven't done the industry, right? They haven't done the. Otherwise, they need to have 4 at least.
Yeah.
They need to have 3.
Yeah.
How could you do one app runs on all? Basically, it's a kernel as a service, and we can do like blockchain as a service. So we just issue ID. When we do ID, can we use Bitcoin? Can we use Ethereum? We just give you ID. Do you know which blockchain we're using underneath? You don't, right? Like on Microsoft, say we have this many APIs that you really don't know whether the kernel is phone, whether the kernel is a database, whether the kernel is a Xbox. Each kernel, actually, they are different. It's just the same set of API. And that API has to be a finite number. If Linux process, as you add functionalities, you add APIs. If you add APIs, you add fragmentations. How are you going to achieve system APIs with a finite number? Actually, that's the holy grail, the ultimate question for the Silicon Valley guys, right? Don't, from Microsoft, don't look down, right? Respect your enemy, respect your competition. And secondly, what they're saying is that because of course universal app could be in Java, could be in C++, could be in JavaScript, they all interact without JNI. Right. Microsoft has already achieved it 2 years ago. And who else in Silicon Valley has achieved it? No, none one. Then why do you respect Microsoft? I mean, they're dying. It's like, should we respect Xerox? Xerox, the guy invented Windows. Right? You know what I'm talking about. We should really pay respect to Xerox, not because of their dying. It's because of their creation. That's exactly why Microsoft deserves respect, even though they're dying. In their graves, you should pay respect. Right? Otherwise, people go nowhere.
Yeah. I got one question. Sorry, guys.
Yeah.
Go for it.
So these side chains that we're gonna have is it theoretically possible to run the existing blockchains that are already out there run as side chains?
We hope to run some of the at the user level. We hope to run some of the popular VMs like Neo VM or Ethereum EVM.
Right.
Because let's say there's a company, there's a group called Quantum. Quantum ported EVM to UTXO.
So I've actually looked into that.
Right. So that said, then can you put the EVM on top of 2-hour web? Right? So then you can have several parties doing the smart contracts just between 10 interested parties.
Right.
Do you have to do it on the public chain? You only need, right? You
only need a few.
Right. So basically, you need exactly the same effort like Quantum. You need to port it over, right, to on top of our blockchain. The same thing. Do you need to port the CRR, whatever Neo is doing, put it on top? And also, if someone else wants to invent their own, because it's much easier than doing a whole public chain.
Right.
So there, we encourage people to do that and contribute back to the code, and we reward them with the ELA or Bitcoin, for that matter.
Thank you.